You know the feeling, right? You build an application, it absolutely flies on your machine, but the second it hits production, it just crawls. Well, today, we're going to go on a hunt for those hidden performance bottlenecks, the silent killers that are secretly slowing your whole system down. So let's start with the question that drives so many developers crazy. Your app is blazing fast locally. Why does it suddenly feel like it's running through molasses the moment it hits a production environment with real users and real data? Well, the answer often lies in all the things you just can't see on your laptop. And just how big of a difference are we talking about here? It's not small. In some really common scenarios, fixing these issues can give you a performance gain of up to 50 times. Seriously, that is not a typo. We're talking about taking a response that takes a whole second and making it finish in just 20 milliseconds. It's a huge deal. Okay, so let's dive in. The main villain in our story is latency. You know, in a world full of microservices, latency is basically the time tax you have to pay for every single network call between services, every round trip to the database. It's like death by 1,000 cuts, and it's caused by all these little network delays and inefficient queries adding up. So if we want to fix this problem, we have to find it first. It is time to go hunting for the specific bottlenecks that are creating all that latency. And we're going to start with one of the most common, most notorious culprits out there. Say hello to the N+1 query problem. This thing is sneaky. It happens when your code makes one totally normal query to get a list of items, let's say 100 blog posts. But then it makes one extra query for each and every one of those items to get related data, like the author's name. So for n posts, you end up doing 1 plus n queries. And what's wild is how innocent this looks on the surface. Step 1, fetch 100 posts. That's just one fast query, no big deal. But then, inside a loop, your code casually asks for the author of each post. And that simple, innocent-looking action, it triggers 100 times more individual queries to the database. So the grand total? A whopping 101 database trips when you could have gotten all the same information in just 2. But look, all this database chatter isn't the only performance thief. How your application manages its own internal work is just as critical. Sometimes the bottleneck is coming from inside the house. And that brings us to this fundamental question developers always face. How in the world do you size your thread pools? If you get it wrong, you're either starving your app of resources, or you're creating so much management overhead that the management becomes the problem. Well, the answer really depends on the kind of work you're doing. For CPU-bound tasks, heavy calculations, the rule of thumb is to have a thread pool that's just a little bit bigger than your number of CPU cores. Any more than that, and you're just wasting time switching between them. But, and this is key, for I/O-bound tasks, which spend most of their time just waiting for a network or disk response, you actually need way more threads. Why? Because while one thread is blocked and waiting for data, the CPU can switch over to another one and get useful work done. This simple change can dramatically boost your app's throughput. All right, now that we've met our villains, chatty databases and inefficient task management, it's time to bring in the hero of our story. And more often than not, caching is your first and your best line of defense against all this latency. The magic of caching is actually pretty simple. It works by storing data you use all the time in really fast, nearby memory. So instead of making that expensive trip across the network to the database every single time you need something, your app just grabs the data from its local high-speed cache. This one simple move completely slashes that inter-service chatter and takes a huge load off your database. Now, when you talk about caching, two names just dominate the conversation: Redis and Memcached. They might seem kind of similar, but their whole philosophies are really different. Think of Memcached as a specialist, like a drag racer. It's a pure, incredibly fast key-value store for temporary data. It does one thing, and it does it insanely well. Redis, on the other hand, is the versatile generalist. It's a full-on data structure server, it can handle lists and sets and hashes, and it even offers persistence, which means your data can actually survive a restart. And you can really see that difference when you look at the numbers. If you're just looking at raw speed for simple get and set operations, Memcached often has a slight edge. That's because of its focused, multi-threaded design. But honestly, both give you incredible sub-millisecond latency. So the real choice comes down to your use case. Do you need the raw, simple speed of Memcached, or do you need the Swiss Army knife flexibility that Redis gives you? Okay, so we've got our tools. Now let's put them to work and see how we can build smarter caching strategies that can directly solve those performance problems we talked about earlier. So there are a few main ways to actually do this.
With cache aside, your application is the boss. It checks the cache, and if the data isn't there, it goes and gets it from the database itself. With write through, the cache takes control of keeping things consistent, writing to the database at the same time it updates itself. And then for maximum write speed, there's write behind, where the cache just tells the database to update later, in the background.
So let's go back to our n+1 nemesis. This line of code looks so harmless, right? You're just looping through some posts and printing the author's name. But behind the scenes, that little post.author.name call is what's triggering a brand new database query on every single trip through that loop. This is a classic performance trap.
And here's the fix. Often, it's just a single change to one line of code. By using something called eager loading, you're basically telling the framework up front, hey, when you go get these posts, I'm also going to need their author, so just grab all of that for me now. And the system can then go build a much smarter query to get everything it needs in one shot.
And this is the payoff. It's night and day. On the left, our lazy n+1 approach just hammered the database with 101 separate queries. But on the right, our optimized eager loading approach got the exact same data in just 2. I mean, that is a massive reduction in database load and a huge win for your application's speed.
So we've looked at some specific fixes for queries and for internal tasks. Now let's zoom out and put all of these puzzle pieces together into a high-level blueprint for a truly performant system.
This diagram really shows how it all fits together. You've got your business logic living in the microservice, and it communicates with a dedicated caching layer. This layer, powered by something like Redis or Memcached, acts as a high-speed buffer. Its whole job is to protect your main database from getting totally overwhelmed with the same read requests over and over again. It's a really clean design that builds performance in from the very beginning. And that brings us to the final thought here. Performance tuning, it's not a one-time fix. It's a continuous cycle of measuring and improving. So you've fixed your code. You've squashed the most obvious n+1 query. Awesome. But what's the next bottleneck? The one that's hiding somewhere else in your system? Honestly, that's the question that keeps great systems fast.